Okay, good afternoon, everyone. We have now come to the last section of today. I am Benny Chen. I'm an architect, and also I am the Assistant Director of Architectural Services Department. Okay, the theme of this session is the healthy city with solitogenic outcome. In this session, we have two very distinguished speakers. Our first speaker, Dr. Chinmoy Sarkar, will examine the subject from a more macro perspective at the urban planning level. Okay? And our second speaker, Dr. Ken Yang, will look at the subject from a more architectural perspective. He will take us through his concept in ecological architecture and green design. The first speaker, Mr. Chinmoy Sarkar, is a research assistant professor of the Faculty of Architecture of the University of Hong Kong. He has done a lot of research in the area of the association between the built environment and the health outcome. Today, Mr. Chinmoy Sarkar will share with us his experience in the UK biobank morphometric platform. Okay, without further ado, I would like to introduce Dr. Chinmoy Sarkar to come to the stage.
Well, thank you. It's a privilege to be invited to speak on the science of healthy cities. And let me take you back 170 years from now into the London cholera epidemic. And this is a graph between the mortality versus in the first 2 weeks around the neighborhoods of the Broad Street pump. Now, John Snow and his team, what they did was to assess the mortality with respect to the various water companies. And they realized that Southall and Vauxhall was in the higher extremity at 315 deaths per 10,000 households. So then it emerged that their supply at the source was polluted with sewage water. So this is a classic example of how spatial epidemiology can combine with urban health, and actually it started the theory of miasma and the discipline of city planning. Now, the question is, as we emerged, our problems have become more complicated. Chronic disease has a very complex etiology with long latency. Now, on the left is a map generated by Charles Booth in the 1890s, and it shows the poverty in inner London, whereas on the right, you have a map generated last year for the prevalence rates of diabetes in inner London, a startling similarity. Again, you have the London smog, 1952, and then now in Southeast Asia, we have the air pollution incidences, as you all now, there's an urgent necessity to reunite urban planning, design with public health and epidemiology. The relationship has waxed and waned over the years, starting from miasma, urban health theory, wherein there was a strong relationship with city planning, thereafter germ theory, risk factor theory. Now we have the more complex hybrid urban health theories. We call it the eco-social epidemiology, wherein there's a strong relationship between the contextual as well as the genetic and physiological factors. Now, what are the challenges? The challenges are sedentary lifestyles, unhealthy eating behaviors, stress, increased incidences of obesity, especially amongst children. That's a very bad scenario in several countries. Increased incidences of cardiometabolic diseases, increased incidences of psychological disorders, with accounting for almost 14% of the global burden of diseases. Then you have significant demographic shifts from the rural to the urban, 6.3 billion by 2050, doubling of the population of older adults, especially in developed economies. And in developing economies, we have the problems of pollution, smog, global climate change, socioeconomic disparity. So just imagine the health costs, of all these challenges. So as urban planners, designers, and architects in this room, what a marvelous idea if we can incorporate health into our decision making as we plan, design, retrofit cities, new cities, existing cities, microenvironments. But then these should be based on real hard evidence. But then as we collect evidence, there are some methodological challenges in existing built environment health studies. First of all, the etiology is very complex. Multiple environmental exposures, small effects, exposures over a period of time, gene-environmental interactions. So we should design large-scale prospective studies which have more statistical power, individual-level analysis as opposed to ecological studies which suffer from modifiable area unit problem, ecological fallacy, objective measures of built environment as opposed to subjective measures of built environment, which are mostly self-reported measures. Measurement of built environment at multiple urban scales so that we are able to pinpoint the exact urban scales which affect a specific outcome, and enhanced automation of the built environment measures to enable replicability across different epidemiologic cohorts across the world. So in order to overcome these challenges, our niche methodology focuses on large-scale data set to understand the etiology, reliable and accurate and standardized objective measures of accessibility, individual level measures as opposed to aggregate measures, multiple spatial scales to capture complex interactions, and data linkage with existing health cohorts so that we can have causality as well as time effects and compare the associations in different parts of the world. Now, the connectedness in an urban scape is a function of general accessibility, connectivity to everything and everyone else, and spatial accessibility, which is connectivity to health promoting, health inhibiting destinations. Now, let's give you some examples. Spatial accessibility. So this is based on the Caerphilly Built Environment Prospective Study, which I was doing in 2009. And Caerphilly is a town in southern Wales. And it has, in fact, the longest standing epidemiological cohort. We started way back in the early 1980s. And these are some of the measures: building center density, dwellings per street segment, plot exposure, dwelling type, property price, land use mix or land use heterogeneity, and street network distances to the nearest green spaces. Now, we are measuring network distance with respect to each and every individual's dwelling location, which is an individual level measure. Network distance to various categories of medical healthcare facilities, network proximity or network distance to sports facilities. Now slope, because slope is important in Wales, so variability in slope, that is one standard deviation variability in slope within 1 kilometer street network buffer. NDVI greenness, normalized difference vegetation index, greenness. And of course we have the index of multiple deprivation, which is a standard index used in the UK at a level of lower super output area neighborhoods. Now, general accessibility, we employ a technique called spatial design network analysis developed by Cardiff University, and it's a collaboration with the Hong Kong Urban Lab as well. And it works on any off-the-shelf network database, and it models a suite of graph-based measures of connectivity with respect to each street link within the network. Now, the basic tenet is based on the principle that if we have a route A to B, and if it has larger angular costs, whereas lower metric cost. Case 2, we have the same route A to B. We have the same origins and destinations A to B, but in this case, we have lower angular costs, whereas higher metric cost. It's generally, it has been generally found out that the routes that are associated with lower angular costs are the ones that are going to be taken. Now, I'm interested in measures of centrality, closeness, and betweenness. Betweenness is the path overlap or the through movement potential, or through movement flows through a network, and in this case, AB has the highest betweenness. Now, so closeness indicates the relative degree of opportunity. Betweenness is through movement flow, and it may be positively, it may indicate the positive effects of demand or negative effects of, say, congestion, traffic density, crowding, etc. So this is modeled betweenness at multiple spatial scales. So we measure them at multiple spatial scales, 1,200 meters, 3,000 meters, and for all the links within the segment. Now, this is one of the first longitudinal studies of the effects of change in built environment, change in body mass index and the built environment. And this was done for 684 adults within the Kafili cohort, encompassing 3 phases. And the key findings were the density of amenities were inversely proportional associated with the body mass index, and higher land use mix was associated with higher body mass index. Higher local level betweenness at 1,200 meters was associated with higher body mass index, whereas at a city scale of 3,000 meters, it was associated with improved weight outcomes. Slope variability was associated with improved weight outcomes, say an inclined exercise effect. Now, the second study we did was to find the associations between urban built environment configuration and psychological distress in older adults of Kafili. And psychological distress was measured through a general health questionnaire. This is a 30-item questionnaire. And we found that in reference to those living in the detached households, living in terraced housing was actually beneficial to mental health. Land use mix was significantly associated with lower odds of psychological distress. Density of bus stops, density of business and offices were associated with higher odds of psychological distress. Betweenness at a local scale of 1,200 meters was beneficially associated with mental health, and slope variability was associated with poorer health outcomes. Now, this is a recent study exploring the associations between urban health, street design, and walkability within London. And this was a study based on London Travel Demand Survey for 15,354 individuals. And we found that the propensity to walk, that is walking greater than 100 meters, was beneficially associated with density of street trees within 1 kilometer street buffer, beneficially associated with betweenness at 400 meters. However, there was a negative association at a mesoscale of 3 kilometers. There was a beneficial association as well with the accessibility to service destinations measured at the lower super output area level. And in this, as a sensitivity analysis, we found that the actual distance walked was beneficially associated with 0.5 meter resolution normalized difference vegetation index, which is an index of greenery, as well as with the density of street trees. And this is a book that came out last year and talks about all the pilot studies before the big study, which is the UK Biobank Urban Morphometric Platform. It's supposed to be a nationwide resource for evidence-based healthy city planning and public health interventions. And what is a biobank? The biobank is a cohort of 500,000 people, 40 to 69, and registered to the National Health Service. It's based in Clinical Trials Service Unit, Oxford University, and the participants reside 25 miles within 22 major cities of UK, extensive baseline data on socio-demographic, lifestyle, medical history, anthropometrics, as well as on biomarkers. The key features include accelerometry-based objective measures of physical activity, imaging measures, including body fat distribution, which will be available for 100,000 individuals, 24-hour diet recall questionnaires. Now, this is a step change in the methodological rigor in which the built environment health studies are conducted, as large sample size ensures that people having a chance of developing various categories of diseases can be captured. Now, the UK Biobank Urban Morphometric Platform is a high-resolution database of 750 plus urban health morphological matrices, or morphometrics. And they have been modeled for each, at an individual level for each of those participants of the UKB, and includes state-of-the-art spatial and network analysis techniques on multiple national level data sets, including UK Ordnance Survey, Master Map, Address-Based Premium, Land Registry, NAPTAN, Blue Sky, Digital Terrain Model, as well as a sub-meter resolution color infrared image. So UK BUMP is linked to the UK Biobank Health Database, and it acts as a platform for healthy cities research. Here in Hong Kong, the Healthy High Density City Lab is leading the collaboration along with the University of Oxford, this Clinical Trial Services Unit, Department of Psychiatry, University of Cambridge, Land Economy and CEDAR, Cardiff University, as well as the UK Ordnance Survey. Now, this is a spatial distribution of the cities, and the biobank participants come within 25 miles of each of the cities. Now, the basic conceptual model is that what we call as the health niche, each individual is surrounded by a hypothetical hypervolume, which is epidemiologic triad of person, place, and time. Now, the hypervolume emerges as a result of interactions taking place at multiple urban scales. At the individual level, you have the physiological, genetic factors, which can be captured by biomarkers. At the lifestyle, then at the meso level, you have the lifestyle level factors, which are prevalent, whereas at the macro level, you have the built environment, natural environment, and social environment. Now, this health niche is dynamic in time, so that our health emerges with time. And also, we have to take into consideration the scales from individuals to population, as well as the planning and the policy scales from local level to the national level. Now, in the biobank, what we did was extract the address database, then we geocode the actual participants' dwelling by comparing or address matching it with existing spatial databases. Then we delineate neighborhoods around them. Thereafter, we have multiple national level spatial databases upon which we perform spatial and network analysis techniques so that we have the urban morphological matrices at an individual level, and then we link it back to the UK Biobank health database. Now, 750 built environment morphological matrices include densities of more than 200 categories of health promoting inhibiting destinations at multiple spatial scales ranging from 500 to 2,000 meters. Network proximity to 36 health-specific destinations, density and street distances to nearest for 19 different categories of food outlets. This was done only for 50,000 individuals within the Greater London Borough, whereas others are for the entire 500,000 people. Now, the street-level physical accessibility, we use SDNA to model street-level physical accessibility indices, including network centrality, network detour, network shape, efficiency, link characteristics, and radius at 19 different catchment area ranging from 400 meters to 50 kilometers. And then they are linked to each and individual UK Biobank respondents' dwelling location. Now, residential densities, building type, and age. Then you have sub-meter level color infrared image to measure the greenery, urban green, in terms of normalized difference vegetation index. And we calculate the mean and standard deviation in greenness within 500 meters buffer. Digital terrain model is used to calculate the slope variability within 0.5 and 1 kilometer Euclidean buffers around a participant's dwelling. You have the index of multiple deprivation, as well as the property price for individuals, as well as within the postcodes. This is a paper that got published and that talks in detail about the UK Biobank Urban Morphometric Platform. Now, the plan is that we do this in two phases. In phase one, we'll study the generalized associations between built environment attributes and health outcomes for the entire cohort. In phase two, we'll be more specific. We'll do natural experiments on the subset of the cohort based on the already measured risk profiles, so that if we have a population who are more prone to mental health disorders, so we'll perform a study on mental health and cognitive function versus exposure to green in suburban and rural communities. Now, as of now, there are approximately half a dozen studies ongoing, and these include urban density versus physical activity, obesity, diabetes, and hypertension for 150,000 individuals, NDVI greenness versus physical activity, obesity, and body fat, percentage body fat, and CHDs. Similarly, urban morphology at multiple spatial scales versus physical activity, obesity, and percentage body fat, access to food outlets, how they are moderated by socioeconomic deprivation versus their associations with physical activity, obesity, and percentage body fat and diabetes. And in the domain of gene environment study, we plan to conduct a study on the actual association between telomere attrition or telomere length and CHD versus the exposure to urban green and socioeconomic deprivation. Now, I'll leave you with some of the images. So this is a street level accessibility map betweenness at scales of 400 meters and 3 kilometers. This is the betweenness measured at 50 kilometers at scale of urban scale of 50 kilometers for South Wales. It is Swansea, Cardiff, and Bristol. Then this is a slope map, for 5-meter resolution slope map for 3 of the UKB centers, which are located in Swansea, Cardiff, and Wrexham. And this is an NDVI 0.5 meter resolution NDVI image derived from color infrared imagery for the London, Greater London, and this is the actual color infrared image. And you can also see a layer derived from the UK map, which shows the street trees. This is actually the network green, which study which we are presently doing, which is measured as a buffer within, there's a 15-meter buffer along each street links. So mean NDVI 15 meters on either side of the street center line for each and every link within London. Now, I'd like to conclude by saying that there's an increasing necessity to take into account the individual health and the economics of it into the equation while we plan, design, construct, retrofit cities, buildings, microenvironments. All our decisions should be governed by hard evidence. We need to raise our game. There's a strong need to collaborate with public health and epidemiology to overcome the current urban health challenges. The UK Biobank introduces a step change in the methodological rigor in how the built environment health studies are performed and is expected to provide robust evidence at large scale for urban health professionals and researchers. Thank you.
Okay, thank you very much for Dr. Sarkar's very enlightening speech today. And Dr. Sarkar has given us a new perspective in, has given us insight to some new perspective in urban planning. Because I think before we thought that, we have thought that urban planning is largely something of a very subjective design or planning process. And Dr. Sarkar now has given us some insight that we can turn it into something with a more objective or with a quantifiable criteria. Okay. Now, before Dr. Sarkar leaves the stage, we can take a few questions before we invite the next speaker to come to the stage. So, any question from the floor? Okay, a gentleman here.
I think it's great to present this to an audience. I've seen parts of this presentation at Hong Kong University. I guess one of the challenges, though, is that we are operating in real time as designers, as engineers in shaping our environment. And the question I have is how long will it take to actually put together this kind of data with the kind of cultural filters that we'll have to use for, say, a China, an India, these places that are growing very fast. Because obviously the UK is a stable population. You have a great database in the UK. It's probably the best database in the world. What do you do for a place like India? Because that's really where the challenge is today. Or parts of China, other parts of Southeast Asia, Africa.
Thank you. It's a very good question. And well, with respect to developing, studies like these are based on spatial databases, the availability of spatial databases, which should be highly accurate, and which are basically updated over periods of time, so that because these are sort of longitudinal studies, sustained effect of built environment upon health. And the UK bump project actually started in 2013, and it's still ongoing, and we expect to finish it by 2000. So it's around 2016 August. So we have around 3.5 years to do this. And at this point, the UK Biobank actually did the first wave of survey from 2006 to 2010, and thereafter we'll have to update it as well. So, and now we are planning to replicate these for 50,000 individuals in Hong Kong family cohort, as well as in Australia, collaborations with this University of Melbourne. However, the challenge really is, how do we do this for developing countries like India? For China, we are on the process of collaborating because China has got the Kadoorie Biobank, which is again based in Oxford, and they have 500,000 people enrolled in that. As far as India goes, India doesn't have a strong GIS spatial database, I'm afraid, because I happen to be from India. So I do agree that for developing countries wherein the population, there's a demographic shift, increasing demographic shift, we need to actually, first we need to build those infrastructures, data infrastructure for a developing country like India.
Okay, any more questions? Okay, if there's no more question, then I would like to thank Dr. Sarkar once more for his very wonderful speech. And I have a little souvenir for him. Thank you.
Thank you.